Welcome to Homework Lib.
Here we're given the value for the equilibrium constant for the following reaction. This equilibrium constant is going to be very positive, so the reaction is almost complete. Meaning that if you do a nice table, what is going to happen is that the equilibrium concentration of the reagents is going to be very small. So, in the first scenario, suppose that a 22-liter reaction vessel is filled with 0.63 mole of Cl2 and 0.63 mole of CHCl3. What can you say about the composition of the mixture in the vessel at equilibrium? So, what we can say about this composition is that there will be very little of the reagents since K is large. The equilibrium constant is large. To see why this is going to happen, let's go on detail on the origin for this. And for doing that, let's begin by doing an ice table. So over here, what we're going to have is that the initial amounts of mole, over here, everything is going to be in mole instead of molarities, just for sake of simplicity and to not be dragging out numbers like crazy. What we're going to have is the initial amount of mole and the initial amount of mole, both of them are going to be the same. 0 and 0, the amount of change would be minus x plus x plus x. So we would end up with n0 minus x, n0 minus x, x, and x. Okay? We can replace the n0s if you want by initial concentrations. It really doesn't matter. But what we know is that the equilibrium constant needs to be equal to concentration of HCl, concentration of CCl4, divided by concentration of Cl2 times concentration of CHCl3 at equilibrium, and this would be equal to x squared divided by, if you want, either n0 or initial concentration minus x squared. So the solution to this equation would be with the initial concentration equal to 0.63 mole divided by 22 liters, which is 2.86 times 10 to the minus 2 molar. You would find that the value for x is, actually you're going to find two values for x, but one is going to have physical meaning, which is 0.027, 27.2, and the other one is going to not have a physical meaning because it is going to be larger than the initial concentration. So the value for x would be this one, and what this is going to produce is that the concentrations of Cl2 and of CHCl3 are going to be very small. So without doing any calculations, we just need to look at the value for K to know that we're going to have a lot of the products and very little of the reagents. But if you want to follow the mathematical procedure, this is how to do it. And for the other questions over here, what is the equilibrium constant for the following reaction? In this case, we're going to have the inverse reaction. So the equilibrium constant would be 1 over the original reaction. Remember, this would be the same thing as flipping out the numerator and the denominator on this expression over here. So this is going to be directly equal to 1 over 382, which reduced to three significant digits would be 2.62 times 10 to the minus 3. And for the next one, we're going to have double the reaction. The original reaction. So in this case, this equilibrium constant, the new one, would be the original squared. Since the stoichiometric coefficients are going to be doubled, what we need to do is, from the original, you would need to square all of the factors. So in this case, the result would be K original squared, so 382 squared up to three significant digits. This would be 1.46 times 10 to the 1.46 times 10 to the 5. And with that, it would be all. Thank you very much and have a good one.